Okay, this is lecture 20, and we'll be talking about polynomials. In the first part for this first video, we'll define polynomials, and then we'll go into addition, subtraction, and multiplication. Okay, so this is the formal definition, and I know it looks kind of intimidating, but let's just look at it and see what it means. So a polynomial is an algebraic expression. Remember, an algebraic expression, all that means is it's a combination of letters and numbers. We've combined them with addition, subtraction, and multiplication and division. Where each term, remember a term is a group of things that are glued together with multiplication. So our terms are separated with plus and minus signs. So again, from the beginning, a polynomial is an algebraic expression where each term has the form a times x to the n power. The important things to know there is that the exponent on the variable, the n, has to be greater than or equal to 0, so we can't have any negative exponents. N needs to be an element of the integers, so we can't have any fractional exponents. And a, the number in front of x, is any real number. So here's some examples. All of these are polynomials. 7x squared. 7's a real number. 2 is a positive integer, so it meets all the requirements. How about 7x? That doesn't have an exponent. Good. 7x is the same as 7 times x to the 1. How about just x squared? That doesn't have a number in front. Good. It's just like having a 1 in front. Now how about this last one, 7? Is that a polynomial? Now remember our rules of exponents. It really is, because 7 is the same as just x to the 0. If there's nothing there, it's like there's just an x to the 0. So 7x squared is 7x squared. That's easy. 7x, we can think of that as being 7 times x to the 1 power. X squared, we'll think of that as just being 1x squared. And if we just have a plain old number, it still qualifies even if there's not a variable there, because we could think of the variable having a 0 exponent. So all of these are called monomials. We're studying polynomials, and poly means many, so those have many terms. These just have one term. Since we don't have any subtraction or addition signs, they are just a single term. So here's some binomials. Those have 2 terms. Trinomials would have 3 terms. Polynomials would be all monomials, binomials, trinomials, and things with more terms. So there's a lot of examples. Okay, notice in each one of those that every term meets the requirements for being a polynomial. The main thing I'm looking for is I don't want any negative or fractional exponents or variables and denominators. So convention, polynomials are usually written in descending order according to degree. That means the term with the highest exponent is written first, and then the next highest exponent is written next, and so on. The coefficient in degree of that first term, when it's written in descending order, is called the leading coefficient and the degree of the polynomial, respectively. So let's look at the examples we had before. We have our little monomials, our 7x squared, 7x, x squared, and 7. We have our binomials, 2x to the 4th minus 7, and 5x squared minus 17x to the 29th. And then our trinomial, and then some bigger ones. So if we write these in descending order, for the the monomials, they don't change. There's only one term. There's no way to write it differently. How about the binomials? Look at 2x to the 4th minus 7. Good, that's already in descending order. It doesn't matter that 7's bigger than 2. We look at the exponents. Since that first guy has an exponent of 4, he goes first. And the 7, we think of that as having an exponent of 0, so he goes next. For the next one, 5x squared minus 17x to the 29th. Okay, I want my x to the 29th to come first, so I'd have negative 17x to the 29th plus 5x squared. Okay, the next one. My x to the 12th needs to come first, so that's good. Then my 7x, then my minus 3. All right, then for the next one, when we have 4 terms, the x to the 7th comes first, and then the z to the 7th, and then the z cubed, and then the z squared, and then the 4z. Now what about that last one? Did you spot it? Not a polynomial. Very good. So these are the polynomials written in descending order. Okay, if we look at the leading coefficient, the only thing we're looking for is the coefficient in front of the first term and the degree of the first term. So the coefficient for those first ones are 7 and 7, and then 1, even though nothing's written, and then 7, 2, -17, 4, and -1. So those are my leading coefficients. It's just the coefficient of the term that's written first when it's written in descending order. And finally, the degree. The degree, I just look at the exponent of the first term. So for the first two, it's 2 and then 1 and then 2. Now remember that's 7 times x to the 0, so the coefficient of that guy is 0. Then 4, 29, 12, and 7. So that is just our definition of a polynomial.